Hi, boys and girls. This is Mrs. Burnett, and I'm here with your instruction today about distance between points on the coordinate plane. On the blog, there were one document that you could open that were the MSG notes and some practice. And so what I would like for you to do is either open them up and print them out if you can, or you can just use your screen like Mrs. Rudd showed you the other day, using the Word document and the draw tool. If you open up the Word document, and you can use the pens, select the color that you want, use a marker to plot points on the graph. That makes it easier for you to do. I think it's better if you use pencil and paper and write it down, but not everybody has the ability to print out the document. So I want you to know that you can still go through it and write on the document by using the draw tool. I'm going to switch over though to the document camera and what I'm writing on, because that just makes it a little bit easier for me. But there's your eraser. So here we're going to be talking about distance, and there are two ways that you can find distance on the coordinate plane. We looked at this before the break. When we just had a positive or a negative number, we plotted it on a number line, and we counted, we used the absolute value, adding those up to be able to find the distance. This is similar, but now we have a set of points, a coordinate pair, and we can use a set of points to do the same thing as well. So it says when two ordered pairs have the same x or y coordinate, they're on the same line. The distance between these 2 points can be found by counting the spaces between the points. Well, that's super easy if you have a grid. Point A is -3, 3. Point B is 2, 3. Here they are plotted out. It's easy enough for us to count the distance 1, 2, 3, 4, 5. And if we're trying to find the distance between A and C, they happen to be on the same line because A is at -3 and C is also at -3 on the x-axis. They're 3 away from the y value. So you can just count those as well. The thing that I want to remind you of is that distance is always positive, all right? That if you travel 5 blocks to school, forget your lunch, and travel another 5 blocks back, you've gone 10 round trip. So we're going to be looking at absolute value as a way to calculate distance. We all know how to count. That's basic. But the great thing is that sometimes there won't always be a coordinate grid to look at and go count. So we can look at our points to be able to calculate that distance using the absolute value. Because I'm sure there were a couple of you last week who were saying, I just don't get this absolute value stuff. But we said, hey, remember, you're going to come back to it. So let's make sure that we understand what's going on. Notice that point A is equal to -3, 3. B is 2, 3. So the values, the y values, are the same. That meant they are on the same line, okay? They are 3 away from the x-axis. Here's their x-axis, the horizontal axis, and y is the vertical axis, and they're all 3 away. So our x values are the ones that are different, and those are the things that we're going to be looking at, the difference of those numbers. They have the same y coordinate, which is 3. That means you're finding the distance between the x coordinates, which are -3 and 2. -3 is 3 units from the y-axis. So we can see that here, 1, 2, 3. And 2 is 2 units from the y-axis, 1, 2. So we're taking the absolute values of those numbers because distance can never be negative. We're taking the absolute values and saying 3 plus 2 is equal to 5 units. And that's how we can use absolute value to calculate distance. The reason why we want to be able to calculate distance using absolute value is because sometimes we won't always have the coordinate grid to go along with it. This looks like the easier example, but we're not going to start there. We're going to start over here with this example that has a triangle, and we're going to use distance to be able to figure out the area and perimeter of some polygons. We've done that with formulas, but now we're going to talk about how you can use the coordinate grid or coordinates to find the area or perimeter of polygons. So some of you may be saying, I cannot really read those numbers. And Mrs. Burnett was the same. She could not read those numbers very clearly, so she had to get out her magnifying glass. A lot of my students laughed at me when I told them I had a magnifying glass at home. They said, like, how could that be? Why would you have that? And I go, well, I am getting older and I don't see as good, but sometimes numbers are really teeny tiny, and that's how they are here. So if you have a pencil, I would suggest that you get a pencil and at least a sheet of paper so that you can write some of this stuff down on a sheet of paper because it'll be harder for you to draw on the screen. So let's write down the points for A. It is -2, -1, because I go over 2 in the negative direction from 0 and go down 1. The points for C, I'm going in a positive direction 4, so the coordinates are 4, and then I go down 1, -1. And point B, it's on the same line as C, so it's going to have the same x coordinate over 4, and then if you can read that number, it's +7. So now we have a triangle. We have our coordinates, and we've labeled them, and I would suggest that you label the points with the coordinates because in your practice work, you'll need to do that. So let's look at one way, okay, to find the distance between points. We count them. Easy enough. We're finding from A to C. Here's the point. That's not 1. I have to go a distance before I can count 1. 1, 2, 3, 4, 5, 6. So the distance is 6. Easy enough. I can count here. We know it's 0 to 7. So 1, 2, 3, 4, 5, 6, 7. And I go one more, and that gives me 8. So I've done what I think is the easiest way to find the distance by counting. Although we did this before, and some people like to start 1 at the point. Remember, distance, you have to travel somewhere. So from this space to that space, that's 1. All right. Well, why have I learned that I can use absolute value to add the different coordinates? Well, I'm going to show you how that works too. Even though our whole goal is to find the area of this triangle, let's make sure that these numbers are correct. So if I want to find the distance from A to C, I look at my coordinates. If I notice my y values are the same, -1. We are on the horizontal line, -1, 1 from X in the negative direction. Those numbers are the same. I'm not going to add them. I'm not going to do anything with them. I want to look at the values that are different, -2 and 4. 1 is in this quadrant. This -2 is in quadrant 3. This +4 is in quadrant 4, all right? And it's a +4. So we're going to add the absolute values to find the distance. The absolute value of -1 plus the absolute value of 4. That is equal to 2 plus 4, 6. And 6 is what I got right there. When I am looking at the distance from B to C, they're on the same line. The numbers that are the same for these two values happen to be 4 because they are 4 away, 1, 2, 3, 4, from this y-axis. They're in the same line with the y. They're the vertical line. So I don't do anything with those numbers. I look at my numbers that are different, and those would be 7 and -1. And so I'm going to add those absolute values. The absolute value of 7 plus the absolute value of -1 is equal to 7 plus 1, and that's 8. So now I know that my counting, I did correctly. But I want you to remember 2 ways to find the distance between points. Now, we're going to get to finding the area of triangle ABC. We use their formula. Area is 1/2 the base times the height. Don't want to forget our 1/2. The base is 6 and the height is 8. So we can put 1s in the denominators. And we get 48 over 2, which is equal to 24 units. If we look at this example now, you'll notice that these are in the same quadrant. All of my numbers are positive. So we can find the distance is 6 units. I did that one by counting. I can go 1, 2, 3, 4, 5, 6. So I counted, but I can also use absolute value. The absolute value of 9 is equal to 9, and the absolute value of 3 is equal to 3. But would I add those numbers? They're the same. They're both positive. So that's when you would subtract absolute values to get 6. Because if you had added them, they would be 12. And you know that's not right. So be careful when numbers are in the same quadrant, you are going to be subtracting their absolute values. I think that's an unusual example for the work that we had to do. So your assignment today is to do this page. And I was going to go through these with you, but I think you've already heard me talk enough, and I think you can do it by yourself. Use this page as a guide, and then just follow the directions very carefully. Write the ordered pair next to each point on the graph. If you look at that, I'm going to run out of time in just a few minutes, but I would recommend that you write the coordinate pairs here. Like go A is -2, 1. So this will be some good practice for you reading a coordinate grid. B, +3, +1. C, and you would want to write the ordered pairs for all of those. And then when you are asked to determine the length, certainly you can count boys and girls, but I'd like for you to try to look at absolute value as well. Remember, perimeter is the distance around. All right, the distance around. You're adding this length and this length and this length and this length. An area of a rectangle is the base times the height. So you're on your own. We'll post the answers and you can check those out. I know you've had to listen to a lot today, but I think it's important that you recognize why absolute value, why we learned about it, and we learned about it so that we could find distance between points on the coordinate plane. Have a good day.